Hi, this is Richard C. I'm a math tutor here at Wyzant, answering a question submitted by a student. This is really a great example if you're just going to do exactly what you're told and not really think about what's going on graphically. This is a good a good example of how that can get you into big trouble. So we're just going to first I'm just going to start by, pretending that I'm just going to just graph this. I'm just going to um, take do the integration without thinking about what's going on with the graph. So the integral of f of x dx, we want the integral, told to find that from 1 to 13. Okay, so we're going to break this up into two parts. From 1 to 7, the function f of x is negative 2 dx. And then we'll go from 7, definite integral from 7 to 13. And it's positive 4 dx. Okay, and then we'll just evaluate this. So this is negative 2x going from 1 to 7 plus 4x going from 7 to 13. Okay, so far so good. And then this is going to be negative 14 plus 2 for the first integral plus 52 minus 28 for the second integral. And that's equal to negative 12. Oops, sorry. Negative 12 plus 24, which equals to 12. And you would turn this into your teacher, and you might get it right because of the way the question is worded. You were told to integrate, and you integrated. But why do we use the integral in real life, and generally speaking in calculus? It's because we want to try to find the area under the curve. And if we just blindly go through this, we're going to think the area under this piecewise function is 12, which it's not. So let's take a look at the graph. So the function's defined, the domain is from 1 to 13. Here's 1, this is 7, and then this is 13 here. And the function has a value of negative 2 from 1 to 7. So this will be a 2 here. It's a piecewise function. It's got a solid point here because the less than, greater than or equal to 1. And now open on 7 because it's strictly less than 7. And then the other one runs from 7 to 13 and it has a value of 4. And it's going to start here and end here with a closed dot. So now if I asked you, okay, well, what's the area under the curve? Well, you don't have to have any calculus at all. You can just use geometry. And you'd say, well, this is a rectangular area here, this space. Oops. Sorry, I meant to change color. This is a rectangular space here. And I know the area of a rectangle, that's just 7, it's 7 long and 2 wide, so the area here is 14. And then this is another rectangular area right here. So from 2 to 13, I'm sorry, 7 to 13. So that's 6, and then it's 4 high, so it has an area of 24. So let me put the 24 over here. And then you would say, oh, well, the area under this curve is 24 plus 14. And that would be correct. Absolutely correct. Your answer would be 38. Oh, sorry, 24 plus, yeah, 14, 38. Okay, and the reason for that is an integral can come out negative. So in the world of calculus, you can have such a thing as negative area. And this is a good lesson for you to remember, which is why I wanted to answer this question. If you look at the question, it's trivial, right? Absolutely trivial to take these integrals. But you can see if the question had been worded the area under this curve, you would have gotten the wrong answer because you would have found a negative area. Oh, you know what? Hold on a second. This is 12, isn't it? I apologize. That's 12 because it's 6 from here to here. I keep thinking that. All right. So it's 6 times 2, and then from here, 7 to, this is 6 long, and here 4 high, 24. And so now it matches what we're getting from the integration. But that's the whole point, is that sometimes you can get something that you can think of as negative area, which of course makes no sense. So you just have to be careful about how the question is worded. Okay, so that's it for this lesson. I'll see you guys next time. Bye-bye.